There's the asymptote at -4.
Okay.
There's
the asymptote too.
Okay.
is it because it's bigger on top? Like
All right. So let's go through this one together. We'll talk about all the pieces. So first, your domain. We've talked about domain before. What are you gonna tell me?
it is not -4.
It is not -4. So you could write like negative infinity to -4, -4 to infinity, right? We're skipping -4. Yes? Review, right? We're good with that. Okay. So do we have any holes?
Yeah.
An asymptote, you're right. So none on the holes, but we do have a vertical asymptote at x equals -4. Okay. So guys, you can go ahead and sketch that on your graph. Because everybody with me on why it's -4? We're okay with that? All right. So vertical asymptote, 1, 2, 3, 4. Okay. Horizontal asymptotes. So let's talk about those a little. This is the whole top heavy, bottom heavy, or equal. We've talked about it a little bit. When it is top heavy. First, what am I talking about when I say top heavy? The degree. If it's top heavy, what do we have? We have a slant asymptote. Yes, okay. It's sometimes called an oblique. Yeah. Okay. And you have to do long division for that. Okay. Do we have top heavy in this problem?
Yeah.
No. Okay. All right. What if it's bottom heavy? Then it's just y equals 0 for your horizontal asymptote. Okay. And again, we're talking about the degree being bigger in the denominator. That's bottom heavy. Third one is equal. You divide leading coefficients. Okay. So this one, do you guys see how this is equal?
Yeah.
Okay, so when I divide my leading coefficients, I'm just looking at 2x over x. What do I get? 2, so you have a horizontal asymptote at y equals 2. So I should draw. Okay. All right. Do I have a slant asymptote? No. You're either going to have a horizontal or a slant. You're not going to have both of those, okay? All right, now y-intercept. What is my x value if I'm on the y-axis? If I'm on the y-axis, what is my x value? 0, right? If you're on the y-axis, what is your x value? 0. So that means I plug a 0 in.
What? 3 over 2.
Okay. So that is a point on your graph.
3, 0.
Okay. Now x-intercept, guys, that's when you are set the fraction equal to 0. And guys, if I want a fraction to equal 0, which part of the fraction actually has to equal 0? Yeah, just the numerator, right? So I'm really just doing 2x minus 6 equals 0. Are we okay with 3?
That's what I was doing.
Okay, so it's the 0.30. Okay. Right there. Okay, to make our graph, we need a couple more points. You need at least 2 points on each side of the vertical asymptote. So I already have 2 on the right. Like, you could go ahead and sketch the shape there. I would be fine with that. You follow your asymptotes and use the points that you have. But we need to find a couple points on the left side of that vertical asymptote. So the asymptote's at -4. So what would you like to plug in that is on the left side of negative 4? Negative 5. And you are literally just plugging it in. 2 times negative 5 minus 6 over negative 5 plus 4. Negative 16 over negative 1, which is 16. So negative 5, 16. That is somewhere way up here, right? Okay. Let's just... You can plug in whatever you want. What do you want to plug in next? I'm going to try negative 6, but you do whatever point you want to over there.
Negative 6 is no.
Yep. Negative 6
How many are
is...
negative 7?
Okay.
Did you just do negative 7?
Okay. Do negative 7. Do negative 10. I don't care.
7 is.
All right. I have 2 points. It's enough to guide your shape. Okay. So follow your asymptotes. Connect your points.
Negative 7 there is 20 over 11.
So 10.5. Or no, 20 over 11. Sorry, I said 20 over 11. Doesn't seem right.
I did it really quickly.
Shouldn't it be over negative 3?
I didn't want anyone else to take it. Okay. Oh. It's no, it's negative 20 over negative 3.
So almost 7.
Almost 5. No, almost 7. No.
Almost 7.
Okay, I'm not the only one who's bad at mental math.
All right, guys, are we okay with that one? Yes? Is this familiar? Okay.
Oh my goodness.
Okay, let's try this one. All right, so let's go through this one. Okay, guys, what is your domain? X cannot equal negative 1 or 1. So again, you can write it with the proper set notation, or you can do this. Okay. All right, do we have any holes? No. What about vertical asymptotes? Okay, and give me the equation for your vertical asymptote. So tell me like x equals plus or minus 1. I'm going to go ahead and sketch those, which makes a very skinny little middle section of our graph here. All right, guys, what about your horizontal asymptote? Is this top heavy, bottom heavy, or equal? Bottom heavy, so what does that give us? 0. So what does that tell me about my slant asymptote?
Non-existent.
Exactly. All right, so y-intercept, remember that's where we plug 0 in for x. What do I get? Negative 1. So 0, negative 1. There you go. What about my x-intercept? Negative 1/5. Well, that's just lovely, isn't it? Okay. Oh, and I did not draw this. Okay, guys, how many of you are freaked out by the fact that we have a horizontal asymptote of 0 and we have an x-intercept? It does. Guys, horizontal asymptotes are not like vertical asymptotes. You can actually cross them. All a horizontal asymptote does is it tells you about the end behavior of your graph. So, like, we know our graph, whether it's here or here, it's going to follow this asymptote as you go towards infinity. But in the middle of your graph, all sorts of craziness can happen, okay? So don't panic. You didn't do anything wrong by getting a point on the x-axis there. Sounds beautiful. I know, guys, you would be heartbroken to miss this class on Tuesday, but...
If we did get a snow day, would we like have work with the snow day?
I don't ever give you work on snow days.
Oh, we can't, I'm sorry, I
No, yeah, sorry, guys, but I don't. I think you should, it's like a gift. You need to enjoy the snow day, okay? Yes. You cannot factor out an x plus 1 from the top. Like, you cannot take a 5 out. Yeah, you see it? Okay. I'm right. Okay. I'm gonna turn into I'm right. At least you didn't say you're wrong. That would have worked. Okay, guys, let's graph the rest of our points. So I need 2 points on the right. I really need another point in the middle, and I need 2 points on the left. So let's start on the right. What do you want to plug in? 2? Sure. So 5 times 2 plus 1 over 2 squared minus 1. What do I get? Close. 11 over 3. All right. What is that almost?
12.
No. 4. Okay. So when you're plotting your point, you're going to go over 2, and then you're going to go just below 4. Like, this is not expecting exactly where 11/3 is, but you need to be in between the correct integers, okay? So over 2, 1, 2, 3, not quite to 4. Okay? I need 1 more point over there. Should we do 3?
Yeah.
All right, so 5 times 3 plus 1 over 3 squared minus 1. What do I get? 16 over 8, which is 2, right? Okay. So that was nice. All right, so we can draw that side. Yes, we okay there? All right, now guys, the reason we need 1 more point in the middle, we need to make sure we have the right shape, because sometimes in the middle it'll look like a cubed graph, sometimes it'll look like a parabola. It's a little weird. We've got 2. I've got a pretty good guess of what it's going to look like, but let's plug in 1 more point. So what would you like to plug in that's like between 0 and 1?
0.36.
No, I don't want to do that.
More place. 0.36. That's a good one.
So 5 times a half, that's 5 halves, right? Plus 1, what does that make it? 7 halves. What is 1/2 squared? 1/4 minus 1?
Holy negative 3/4.
Okay, so think about it. That's like 7 halves times negative 4/3. So, what is that?
Negative 14 over 8 over 6.
Negative 14 over 3. Negative 14 over 3 is almost?
Negative 15 over 3.
Okay, so almost negative 5, right?
I mean,
Okay. So, when I go to a half, I go down almost to negative 5.
Whoa.
So, it's really skinny in the middle here, but it's going to look a lot like, yeah, a lot like a cube. Okay? I don't know if you can even see my line in there. Can you guys even see it? Maybe. All right, so now I just need 2 more points on the left. What do you want to give me? Negative 2. All right, so 5 times negative 2 plus 1 over negative 2 squared minus 1. What do I get?
Negative 9 over
Negative 9 over 3.
Yeah.
So negative 3, right?
Oh, that's nice.
That's nice. All right. What other one do you want to plug in?
Negative 3.
Okay. Whoops, that's a minus 1. So negative 15 plus 1, that's negative 14 over 8. So negative 14 over 8, that's what? Negative 7 over 4. Almost negative 2. Okay, you're catching on. So, follow your asymptotes, and there you go. Okay? Not too bad, right? Okay. Questions so far? All right, we're skipping 3. And guys, number 4, I'm actually changing. I said we skipped number 3.
Skip.
And change number 4 to this. Change it to x squared minus 3x plus 2 over x plus 1. All right, so domain. What's your domain? Yeah, first, you can factor. What does the numerator factor into?
X minus 1, X minus 2.
Okay, so does that actually do anything for us?
No.
It's nice to have.
It is nice.
No, it's not. That's horrible. No one asked you.
All right, so what is our domain? Nothing cancels out, so what's our domain? What can x not equal, guys?
-1.
Okay, so negative infinity to negative 1. Negative 1 to infinity, right? Okay, we established we don't have any holes, right? It factors so nicely and does nothing for us. Okay.
I love it.
All right, vertical asymptote.
I got it.
What?
Slim.
But vertical first. X equals -1, yeah. That's why I make you write the equation so that you know. I know that you know. Okay, do we have a horizontal asymptote or a slant?
Yeah.
Slant this time. So, the way you do a slant asymptote, we're going to start with long division.
Oh, I love this.
You don't complete the whole long division, so it's really not that bad. So start, what do I take x times to get x squared? X squared plus x, subtract, so now I have negative 4x plus 2. What do I take x times to get negative 4x? Minus 4. Okay, stop right there. If I multiply that out and subtract and do all of that, I'm just finding the remainder, right? We do not care about the remainder when we find a slant asymptote, so you can stop right there. So your slant asymptote is y equals x minus 4. How are you going to graph y equals x minus 4 plus like 2 over x plus 1? So you're going to graph the line y equals x minus 4. So let me put in my asymptotes here. So I've got a vertical one at -1. And then how do I graph the line y equals x minus 4? Start at -4. And then it's like up 1 over 1, right? Okay. So our slant asymptote is really that bad?
They're gonna get worse.
Really not though, because all I'm going to give you are linear slant asymptotes right now. Okay. Like, that's a line.
Great.
Because if the degree of your numerator is like, let's say it was an x cubed divided by an x, you'd be getting like a quadratic, like a parabolic asymptote. Yeah, you're not. So you just have lines. You can do lines. All right, guys. So y-intercept. That's where we plug 0 in. What do I get? 2. Okay, so 0, 2. Plot your point. So your x-intercept, how many x-intercepts are there? 2. So remember when God said it was nice to have it factored? He was right.
Oh.
Because then what are the 2 places where I have an x-intercept? 2 and 1, right? So I've got 2, 0, and 1, 0. It's weird, I know. So guys, what that means that's happening with your graph,
Oh, it is.
it's like this weird little, okay? So we need a few points for that little bottom piece though. Are we doing okay, guys? Yes? Okay. What do you want to plug in? -2. So, -2 squared minus 3 times 2 plus 2 plus 1. So what? 4 plus 6, 12 over -1. So -12. So -2, -12, or like way down here. So let's do one more. Let's plug in -3. So that's 9 plus 9 plus 2. So what's that? 20 over -2. -10. Okay, so, like, is it perfect down here? No, you're not going to have everything exactly right, but you can give me that general shape, okay? Does that make sense what your graph looks like? A little bit? Alright, we haven't done any with holes yet, so we should probably close holes.
Wait, how? Oh, no.
You sure?
Like this, like stuff to the right and the left of that. What?
So you've got a vertical asymptote. You'll have stuff on the right and the left of the vertical asymptote, and then you have to figure out like where does that fall with the slant asymptote? Like it's in here and here. Sometimes it might be over to the yeah. That's why you check the form. Okay. All right. We okay? All right. Let's do number 5. Okay, so domain, you should tell me right from the beginning. What is your domain? Okay. Then we'll try to factor. So this is what? X minus 1, x plus 3 over x minus 1. We're okay with that? Yes? Okay. So you guys see that this cancels out, right?
Yeah.
Okay. So we definitely have a hole. I want you to give me the actual coordinate of the hole. So you know the x part is 1, right?
Yeah.
How do I find the y part?
Plug the rest.
Yeah, plug it into what's left. So we are now looking at just this. So when I plug a 1 in, what do I get?
4.
4.
Gosh, I don't know how to do that.
Do you see what I'm plugging it into now?
Oh, because it's plugging into so much.
You can do it. Just plug it into what's left. So I get 1, 4. So guys, what that means is on my graph, I'm going to go to 1, 4 and literally draw a hole. Okay. All right. Do I have any vertical asymptotes? No. That was a hole. It's not going to be a hole and an asymptote. It's going to be one or the other. Okay. You might have a hole and an asymptote, but they would be 2 different x values. Okay, so you do not have a vertical asymptote. Guys, and look over here, this is sort of what we're basing it off of now. So, do I have any horizontal or slant asymptotes?
No.
Now, what is y equals x plus 3? That is just a line, yes. So, we don't have that, we don't have that. What's your y-intercept? 0, 3. And what is your x-intercept?
None. There's no correct.
X equals -3.
-3, yes. So, I can plot those. And guys, just draw it. It is just a line, and you just, you skip your hole. You guys see? Sorry. Are you guys okay with that graph? Yes? Okay. If we have time, we'll come back to some of these questions that are on there at the end, but we're going to move on to partial fraction decomposition right now. I know. What are you laughing?
You don't know left.
All right. So now, essentially, we're moving on to 7-4. We're doing 7-3 and 7-4 today.
Oh, now we're doing actual notes.
This is something new. Yeah, sorry. Sorry. All right, 7-4, partial fraction decomposition. Alright guys, so if I had 2 over x plus 1 over x plus 1, and I wanted to add those 2 fractions together, what would I have to find? Common denominator. I'd be taking my 2 times x plus 1 over x times x plus 1. And I'd take 1 times 2. I mean x. 2. Right. Okay. And x plus 1 times x, right? We're okay with that? And so I would end up with 3x plus 2 over x times x plus 1. We're okay there? Like that's just adding, like you guys know how to do this. What partial fraction decomposition does, you sort of go in reverse. So I'm going to give you like the final piece, and you're going to have to turn it back into those original fractions separated. And you're going to have to find like the numerators of the fractions that would make that work. So like you are going to be finding this 2 and this 1. Okay, so let's do one together. So you would start with, I'd give you x minus 1 over 3x minus 5 times x minus 3. Okay, so like, that's what you would be given. So, let me show you what we do with this. Let me just walk you through it, guys, because this is very new and different. It's not hard, you just haven't really seen it before. So I've got 2 factors for my denominator, right? That means I'm going to have 2 fractions that I break it into. So the way you write that, you're going to say a over 3x minus 5 plus b over x minus 3. Does that make sense? Those are the 2 fractions that you would have to find the common denominator for to combine. Okay? We just don't know what a and b are yet. All right. So I don't know if you remember back in Algebra 2 when you had rational expressions like this, you could multiply by that common denominator.
Oh, this was the worst.
It is not the worst. Lots of things go away now. So on the left, all you have is x minus 1. Yeah, the whole thing. And then a would be times x minus 3. And b would be times 3x minus 5, right? I think that looks a lot prettier than what we started with.
Yeah, I know. But getting to that point,
It was one step.
tedious.
Apparently one very tedious step, guys. I don't know. All right. So if I distribute, so I've got x minus 1 equals ax minus 3a plus 3bx minus 5b. Are you okay with that? All right. Still leaving my x minus 1 alone. I've got 2 things that have x's with them, right? So would you guys understand it if I did a plus 3b quantity times x and then minus 3a minus 5b? You with me now? Well, factoring, that's all. Yeah, okay. Okay, so a plus 3b, that whole quantity, that's the coefficient on x, right?
Yeah.
What is the coefficient on x on the left side? 1. So that means a plus 3b has to equal 1. You following me there? And then negative 3a minus 5b, those are just constants, right? Because a and b are just numbers. So like there's not an x going on with the 3a and 5b. Okay. So what is my constant on the left side? Okay, that's the constant on the right side. And then what's the constant on the left? Okay. So you've said both parts. So negative 3a minus 5b will equal negative 1. All right, you now have a system of equations to solve. Okay. Elimination is going to be the easiest route here. So if I took this first equation, what would I multiply it by? I'm just going to go times 3, so that'll give me 3a plus 15b equals 3, and then I can just add those two equations together. What do I get? 10b equals 2, b equals 5.
No, wouldn't it be 90?
99, what? Did I multiply wrong? Okay. This is a 9,
Yeah.
not a 15. Alright. So how about 4b equals 2? So b equals 2. Better? Yes. So system of equations. So these two are what I started with, right? I want to eliminate a variable. This is elimination with system. So to make these match, I have to take this first equation times 3. So that makes 3a plus 9b equals 3.
Wouldn't you divide by
I don't know. Man, it's a struggle today, isn't it, guys? Okay.
Yeah, okay.
Just making sure you guys are paying attention.
Yeah.
All right, so b is a half. Okay. Yes.
I'm so confused why how you're getting the system of equations.
Okay. So if you look right here, this, I know it's got a bunch of letters in it, but those are just numbers, right? They represent numbers. So this is the coefficient.
Okay, so it equals 1. That makes sense.
Yes. Okay. These, you see how there's no x's with it?
Yeah.
So that's all just a number, like the constant. Okay. And this is the constant. So I'm just doing all of that equals. Okay. Yep. All right. B is a half. How do I find A? Plug it in. So A plus 3 times 1/2 equals 1. Does it matter which equation I plug it into? No. So A plus 3/2 equals 1. What does A equal? Minus 1/2. Yeah. We're all doubting ourselves this morning.
Maybe like there's no X going on, and that's why it's a constant.
So negative 3a minus 5b. A and b are just numbers, right? So negative 3 times a number minus 5 times a number, that whole thing is just a number, as in the constant.
So what is
X is going to be in your final answer. Because you are solving for, you're solving for A and B. You are not solving for X here. Okay? Alright. So, to write your actual answer, we go back to this original thing that we had. And we are figuring out our two fractions here. So instead of A, I have negative 1/2. Well, you don't really want negative 1/2 over, like you don't want a 3-level fraction. Okay, so what you do is you can put your negative 1, 2 goes down there, and then we have what? Was it 3x minus 5? Back at my original. And then you can say plus if you want, or you can just say minus 1 over 2 times x minus 3. Oh, it was positive though, wasn't it? Man. Yeah, thank goodness. Clearly we need a snow day. So guys, that is the partial fraction decomposition. So you have broken it into those original two fractions that if you added them together with a common denominator, you get what I gave you. Nope, you can just tell me this and you're done. Okay, you guys gonna try one. You can do it. I know, it's just forever. It actually, we do have to look at it and figure it out because we've added stuff to this unit. So we cannot just give you what. Yeah, we're gonna have to cut things down and be like, okay, we can only ask you that one way, and is it? This question has to combine 7 concepts, so. Alright, you guys try this one. What are you signing a petition for?
Oh, for increasing spring break by
Oh, okay.
5 days. Yeah, it's a
Yeah. I would rather just have every Friday off in May and June.
Or an extra.
Or 2 hours early for like a month or a month and a half. That'd be nice.
But we can probably still get that and enjoy like one soda.
Oh, absolutely, yeah.
I just don't want to go to school. I just don't go to school. Shut up.
That's not a good plan. It's not that bad.
No, this one was like literally. It gave you one of the answers.
Yes, I agree. It gives you your constant, so you don't have a system on this one.
Because like you can just picture this as like a Y. And so if it was like on this,
Alright guys, did you get it? So did you get 2 over x plus 1 over x plus 1?
Yeah.
Yes?
yeah.
Does anybody need me to go through it? Or are we okay?
Wait.
Yes?
How?
Okay.
What? Was that the first step or is that your final?
That's the answer.
Oh, okay.
I
was like, how did you do that?
I am magical. Okay guys, that should have been your first step, right? Okay? So then I multiply the whole thing times x plus 1, right? So I get 3x plus 2 equals a times x plus 1 plus b times x. Are you there? Yes? What happens here?
Why would you multiply by x plus 1?
You multiply so you can eliminate all the denominators. Okay? I would like there to not be any denominators. So then 3x plus 2 equals ax plus a plus bx. So 3x plus 2 equals quantity a plus b times x plus a. So guys, right away you know a. What is it? 2. Okay? And then a plus b has to equal 3, and a was 2. So what is b? 1. And that takes us back to our answer. Does that make sense?
No, we're trying to get hard.
Oh, I get it.
Yeah?
Factors like the X.
Yes.
Yeah.
Yes, okay. Alright, we're okay with that one? We have to do one more of these, guys, and then we will do nonlinear inequality. We're going to make it through everything, guys. Should work. Alright, this one I'm going to do with you because it's a little different. We will start with 1 over x minus 3 times x plus 1 quantity squared.
That's easy.
It is, but I don't think you know how to do it right now.
We're just a C now.
There is going to be a c. Now, the way you write this, you would have a over x minus 3. This is the part that's weird. You will have b over x plus 1 and c over x plus 1 quantity squared. So, like, if that had been x plus 1 to the 4th, you'd have b over x plus 1, c over x plus 1 squared, d over x plus 1 cubed, and e over x plus 1 to the 4th. I'm clearly not going to give you that. But that's how it works, like it's the progression.
I thought you were doing this one.
No, I saw some very scared faces just like, okay. Does that make sense, what I've done with my fractions?
Yeah.
Okay.
I love a C.
You love a C, okay. Luke, what's wrong?
Why? X plus 1 squared.
Because this is x plus 1 squared.
Did you factor in x plus 1?
It doesn't work if you just do x plus 1 times x plus 1. You have to do the progression. That's what I'm saying. If this had been like if this was squared and this one was to the 4th, you'd have x minus 3. You'd have x minus 3 squared. You'd have x plus 1. You'd have x plus 1 squared. You'd have x plus 1 cubed. You'd have x plus 1 to the 4th. Okay. I agree it's weird. That's just how you have to do them when they're set up this way. Okay. So, what am I multiplying the entire thing by? So guys, x minus 3 and then x plus 1 quantity squared, right? Okay. On the left, all I have is a 1, which is quite nice. Then I'm going to have a times x plus 1 quantity squared. B is going to be times x plus 1 and x minus 3. And C will be times x minus 3.
That's why we discovered.
Okay, do not multiply this out. I have a shortcut for you. Okay.
I want to multiply
It's going to be a little brutal, especially since on the left you only have a 1. You know what I mean? You don't have a lot of pieces to work with there, so
I want to.
you can do it that way. You absolutely can get there, but let me show you the shortcut. So, if I look at that first, my A is times x plus 1. What would make the quantity x plus 1 equal to 0? Negative 1. So the first thing we're going to do, we are going to let x equal negative 1. So with my equation, so then you're just going to write out your whole equation. I would have 1 equals, if I plug it in to the first little factor there, it's going to be a times 0, right? So that's gone. Okay. What about b? Is that also going to be times 0? Yeah. What about c?
Yeah. 4C.
Negative 4c. You guys see it? Could I solve for c then? Okay. So negative 1/4 equals c. All right, now I'm going to let x equal something else. What else do you think I might want to let it equal? 3.
6.
What else is going to give you a couple zeros up there? A 3.
Oh, okay, you're trying to
Yep, so that you can eliminate certain terms. So if x equals 3, I've got 1 equals 16a, right? Okay. And then the b is gone and the c is gone, right? Okay. So I have 1/16 for my a. All right. Okay, I'm out of things that would make things 0. So I need to pick another x value. What's an easy x value to plug in?
0.
Yeah, so let's let x equal 0. Now you're not going to eliminate any of your terms here, but that's okay. So I would have 1 equals, do you guys agree that'd be 1a? Okay. And then minus 3b and minus 3c. You with me? Okay. 3 variables, but don't I already know the value of a and c? Okay, so 1 equals 1/16 minus 3b, and then plus 3/4. It's minus 1/4 times a negative 3, so that's going to make it plus 3/4.
Wait, it's 3 times.
It's negative 3 times negative 1/4, which is positive 3/4. Go ahead, you look like you don't believe.
Oh,
No, that's okay. It's been that kind of a day. It's quite all right.
Yeah. Why do you just let them?
You can't. I mean, honestly, if you were multiplying this out, you'd be setting things equal to 0 anyway, because is there an x squared term, and is there an x term? Like, what are the coefficients of those? So you know on the other ones how we would be like, okay, so over here the coefficient on x was this, so I'll set it equal to the coefficient on x over here. We're clearly going to get x squared over here. Like if you actually had gone and multiplied this out, you look like you don't believe. X times x is x squared.
Yeah,
I found b. So is there an x squared term over here? So what does that mean the coefficient on x squared is? 0, okay? And what about the coefficient of x? 0. And then it's always plus 1. So you'd be setting things equal to 0 here. We're just sort of doing that in a shortcut. Okay. It's not all just made up, I promise. All right, so now we're going to add some fractions. So how do I add 1/16 and 3/4?
it's 13 over 16.
Right, because this is really 12 over 16, right? Okay, so I've got 1 equals 13 over 16 minus 3b, so subtract 13 over 16. So this is really 16 over 16. What do I get?
Negative 1 over 16 equals 3.
Hold on.
Negative 3.
I'd get 3 over 16 equals negative 3b. You with me? Okay, dividing by negative 3, that's the same as multiplying by negative 1/3, right? So negative 1/16 is your b. Alright, so you don't get to stop there, you gotta actually write your answer. So my a was 1/16, so that means I have 1 over 16 times, let's see, what was my first, what did I do as my first, I did x minus 3, okay. Then b is negative 1/16, so I'm going to do minus 1 over 16 times x plus 1. And c is negative 1/4, so minus 1 over 4 times x plus 1 quantity squared. That is your partial fraction decomposition. Okay?
Wouldn't we be negative? Oh.
You good? So, remember your very false
That's all. We're removing all convenience.
well, a is 1/16, so I did 1 over 16. Yeah. Yep. Okay. All right, we're doing okay? We have 10 minutes left. We can do
It's probably half an hour minutes.
No.
More.
Oh, it won't be that bad. Okay, we are going to solve nonlinear inequalities. You have done this before, you just didn't know what it was called. And by done before, I mean this year. I don't mean last year in algebra 2, okay? All right. All right, guys, I'll give you this. X minus 6 times x plus 2 is greater than 0. Guys, this is a non-linear inequality because if you multiplied that together, you would get a quadratic, right? That makes it not a line, okay? It's no parabolic. All right, you have done this before. Remember your number line when you did domain? Yeah, same thing here. So, what are the 2 points on my number line? Okay. Which section do you want to check? What do you want to plug in?
Let's go less than -2. Or not.
You absolutely can, guys. If you want to test all 3 sections, you certainly can. I see that there is no multiplicity happening with either of these factors, right? What that tells me is they're going to alternate. One's going to be positive, the next negative, the next, you know what I mean? It's going to go back and forth. So if you just want to test the easiest section, which to me would be the middle, right? So we can plug in a 0. If I plug in a 0, I get a negative times a positive, which is a negative, right?
It does not work.
It just gives us a negative. That's all I need. So then what's going to happen on the outside edges?
Plus, plus.
Plus and plus, okay? You have to pay attention to what your inequality is asking you now. When we did domain, it was always the same thing, but now it could be different. We could be looking for the negative. We got to see if we're looking for the zeros or not. This says just greater than 0. That's positive stuff, right? So that means not including the -2, but everything over here. Not including the 6, but everything over here. So your answer would be negative infinity to -2, 6 to infinity with soft brackets on all of it. Okay? Does that make sense?
Yeah.
That's your answer. Okay, we're gonna do one more. So guys, obviously sometimes you have to factor before you can set up your number line. You may have to think about what the quadratic is actually doing. The other way I can give you a nonlinear inequality is with a fraction. So x minus 3 over x plus 4 is greater than 3. Last one here, guys. Okay, so when we did our number line, it would always tell us positive or negative, right? Which that's greater than 0 or less than 0. Can't really do greater than 3 on my number line, can I? So I need to bring that 3 over. So I want it to be greater than 0. How do I actually combine fractions?
Oh, you do not know.
Right, multiply by x plus 4 over there, so just be careful with your negative. I feel like with the way this morning's going, we should do this in 2 steps. So guys, that's x minus 3 and then minus 3x minus 12. Does that make sense to you? So we actually have negative 2x minus 15 over x plus 4. Okay there? All right, you are doing a number line again. On this one, we still just have 2 points on our number line. How do you think I'm going to find the 2 points on my number line? What? No idea. What do you think to me? Yes, and? Okay, that's a good start. So you figure out where your numerator would be 0. Okay, so where would that be? Negative 15 over 2, right? Yeah, so negative 7.5, okay. And then where would your denominator, like, what would make your denominator 0? Negative 4, let's just, okay. So negative 2x minus 15 equals 0, so I'd add the 15 and then I'd divide by the 3. It's that kind of day. All right, so it's sort of like when you're multiplying things. Here you're dividing them, so like a negative over a negative actually gives you a positive. Same idea. So I'm going to start over on the right there. If I plug in a 0, what is my numerator? Okay, so negative over, what's my denominator? Positive. Negative over positive is negative. You can check, but what do you think is going to happen? Yeah, it's going to switch, because let's say I plug in like negative 5. What does your numerator become? Negative. What does your denominator become? Negative over negative is? Okay, so that's negative 15 over 2, that's negative 7.5, so let's plug in negative 8. What would you get in your numerator? Positive over negative, right? So overall that's negative. So again, you guys see the alternating. All right, I want greater than 0 this time. So where is that? Between, not including, right? Just, so you would say soft bracket, negative 15 over 2, negative 4. Yes. It says greater than, not greater than or equal to. And guys, even if it said greater than or equal to, would you include the negative 4?
No. No.
As long as there's not multiplicity on any of those factors, you know. But like if it was over x plus 4 quantity squared, then things would be different. Okay? It alternates as long as you don't have multiplicity on your zeros. Like the quantity x plus 4 squared, that would change things. Just think about, you know, your graphics polynomials, that's where it bounces. Yeah. Okay, like I need to tell you something about your I'm telling you to skip some. Let's see.
No, but getting nervous on testing. Okay, great.
I really want you to skip all of those.
No,
Do I have it on?
I was actually kind of locked in during the test.
It's not due next time, though.
No, I don't know what happened.
49 was 30.
Oh.
Guys, I'm not going to have you skip all of these because we already took a few of them off, so don't skip that. This, I just did here. Yeah. You didn't, you're right. You didn't have that on there, so it wasn't there to skip. And then, guys, on page 402, on the assignment sheet, it says 5 through 7 and 13. And I will give you your take-home quiz on your way out here.
Oh, is that 14 pages?
It's not due next time.
It was last year. Before last year. I never got any last year.
Yeah, we'll go with what I have on the screen, okay? Alright guys, you're out. Grab your take-home quiz. I know it's small, so use scratch paper, organize your work on your scratch paper. Not due next time, supposed to be doing snows, and we'll figure that out. Sorry. yet. Because I told you it would be till like 4 when everyone's taking it.
Okay, my mom wants to go with it.
Yeah, I know.
Okay.
Did she show you the list I sent her?
Yes. That's a good list.
Yes. No, she was like,
Yeah. It's like, thank you for actually telling me what I did wrong.
yeah.
I appreciate it.
Very well. Thank you. You're welcome. Maybe these. I don't know what I have. Okay, Chris. Okay. This is way back there. It is understanding. Go, since when is it raining?
It started raining.
Hey. How are you? Good. Hold on, guys. Sorry. Stop my recording.
Woo! But they're not.